Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Good day everyone, welcome again to JD's channel, and for today's topic, we're going to discuss all about helical springs. So let's get started. So for the content, we are going to define what is helical spring. Secondly, light spring and heavy spring. Thirdly, all about spring deformation. And the last part is the spring in series and spring in parallel. And also we will going to solve problem with regards to this topic. So now let's define what is helical spring. A helical spring is a coiled mechanical device which stores and releases energy to absorb impacts or a shock and to resist either compression or pulling forces between objects. So ito class yung example ng ating helical spring. Ano po, as you can see here, siya ay isang, sabi nga dyan is coiled mechanical device or yung wire natin, yan. Ano po, so yan yung ating helical spring or pamilyar naman tayo sa mga spring. Ayan, so bakit ba natin kailangan ito pag-aralan? So technically class, this helical spring is used as a structural support and it experiences stress and deformation. So ayan, which is yun yung ating pinag-aaralan. It's all about stress, deformation ng certain body. So next one, it is typically cylindrical shape. Ayan, as you can see, so itong ating spring na to is siya ay bilog, ayan, so siya ay around a rod, na inikot-ikot, ayan. And features various number of coil according to its intended use. The wires used to manufacture helical spring are generally especially tempered after their construction to give the spring its compression characteristic. Yan. So the next is these springs are usually formed around steel jigs while the wire is still annealed or soft, then tempered or hardened to produce the resilient, resistive quality of the finished spring. With extended use, the tempering may be degraded to the point where the helical spring stretches or sag and no longer functions, depending on the financial implication or worn spring may either be replaced or tempered to restore its original characteristics. So when a closed coiled helical spring composed of a wire of a round rod, so yun nga, yung ating helical spring, it's a wire of round rod of diameter D. So ito class, kung makikita nyo yung ating wire dito is, yan, we have the diameter D here. Okay? Ayan. Ito yon. So, di ba siya ay rod. So round rod. So, ito yun. Meron tayong diameter dyan. And wound into helix. So, ayan, yung ating helix. Okay, so yun yung sinasabi natin helix. Of mean radius R. Ayan, so yung radius ng mismong helix natin, ayan, which is we use capital R, and N is the number of turns. Ayan, so kung ilang ikot, ayan, kung ilang ikot ang na puproduce dyan or nilagay dun sa ating helical spring is subjected to axial load P. So, ayan, may mga, ito, sample nito is ito yung axial force, which is, to be specific, is yung ating tensile force P. Ano po? So, meron din naman class na siya ay subjected to compressive. So, depending nga sa application niya, ayan. And dahil doon, di ba, may applied na force, so mangyayari sa body natin, which is yung ating helical spring, it will experience stress. That is, di ba kung mapapansin yung class, pag yung ating mga spring, pinipilit natin, or ating hinihila, di ba, di ba po ba, ang nangyayari is pumipilipit siya, napipilipit. Ano po? Pumipilipit siya, and ayun, kita natin na pag masyado natin nahila, ayan, nagkakaroon na siya ng deformation, or yan, yung change in length. Ano po? Ayan, so nagkakaroon siya ng hindi lang stress yung nagpo-produce, so nagkakaroon din siya ng elongation. Okay? So, yan po. So next is yan, application of helical spring. So ito, para ma-relate natin siya dun sa mga malimit natin makita sa paligid. Ano po, yung application ng ating helical spring. So una, helical spring are generally used in two different application. The one is the role of compression spring, which offers resistance to forces moving two components towards each other. So yan class, napansin natin kanina, di ba? Itong helix natin is subjected to tensile force. So ngayon naman, pag-aralan natin kapag naman siya ay subjected sa compressive force. Ayan. So, typical applications are yan. So, yung ating car suspension. As you can see class, dito sa ating slide. So, makikita natin yung mga spring na yan, yung mga helical spring natin na yan. So, they are subjected to, ayan, or yung application niya ng ating spring is in car suspension. Yan, ilagay natin sa ating mga sasakyan. And matrices spring. So, ito naman sa ating mga, ayan, matrices natin. Ano po? Sa ating mga kama, higaan. Ayan. So, nandun may makikita rin tayo itong wire or yung ating helical spring na siya yung sumasalo ng bigat ng mga bagay doon. Ano po? And, ayan, may stress din yung ating mga helical spring doon. So, compression spring typically have their ends trimmed in such a way that they lie flush with last coils on each end, allowing for easy mounting. Ayan. So, ito yung isang example at napaka-familiar sa atin. Ano po? Yan, gamit siya in compression. Compression spring. Okay? So, the next one class is the second common use for the helical spring is as a tensioning element. Ayan. So, spring used in this role resist forces moving two objects away from each other. A couple of common tension spring application includes spring scales and automatic door closers. The ends of the torsion spring extend beyond the axis of the spring and are typically equipped with a loop allowed for fastening. Ano po? So ito po class yung ating application na nabanggit kanina. Ano po? Helical spring. So we have this spring balance. Ano po na makikita naman natin. So napaka-familiar naman natin diyan. And also this door closer. Ano po sa mga offices and also sa school. Ayan. Isang example ng ating or use ng helical spring ano po in tensioning. Ayan. The helical spring may also be used in application where energy stored in a compressed spring imparts percussive impact. This application typically see percussive work piece pulled back against the spring tension, then released to strike another object. So, yan. Ito naman yung isang application class kung saan nag-i-store ng energy and then pag ni-release mo siya, it will strike another object. This cycle may be completed in a single action or the striker may be locked in place with the spring under tension for later use. Common example of these uses include yung ating firearm firing pins, detonators or anti-personnel ordnance, and automatic center punches. Ayan. So, yan po yung ating mga example. So, ayan. So, napaka-familiar naman sa atin yan. Firearm firing pins. Ano po? So, nandito yung kanyang spring and yung ating firing pin. Ano po? Nakalak siya and it can be used in future use. Ano? Pag nakalak na siya, naka-lock na. Then, i-release na lang. Ano po? The second one is itong pencil detonators natin. Ano po? So, mayroon din siyang spring. And yan. So, yan yung ating mga examples po. Ano? Ng ating helical spring. So, also class application ng helical spring. Ayan, support in piping system. Ayan. So ito po class, sa loob niyan, yan yung ating support niyan. Naka-cover siya kasi ng bakal, pero sa loob niyan merong spring. Okay, so para mas malinaw, makita niyo dito. Ayan. Ito po sa loob nito class, may spring yan, katulad ng pinakita dito. So yan, ito yung mga spring natin. Nasa loob siya niya. And then, paano siya nilalagay? So yan, as a support here. So, okay, so ayan, para mas stable siya. So, bakit ba dito? So, piping system, nag-iiba siya ng temperature and somehow nakakaroon siya ng vibration due to the temperature change, yung pressure dun sa loob. So, they use spring to regulate yung some vibration at maging stable pa rin yung kanyang system. Po? So, next one is light spring and heavy spring class. So, light spring. So, dito class, we compute for the maximum shearing stress. So, ano ba yung maximum shearing stress natin? Maximum shearing stress is equal to the sum it is the sum of direct shearing stress and which is we assign it as tau sub 1, which is yung kanyang formula is the usual formula that is force over area and ng torsional shearing stress, which is we use tau 2, that is equals to, yan, yung ating general formula for torsional shearing stress, T reduce over ng ating polar, yan, yung ating J, which is yung ating polar moment of inertia. And then with the value of our torque, so ito yung napag-aralan natin, di ba, sa flange bolt coupling. Ayan, so yung ating T, or yung ating T is equals to yung ating, kasi torque is a twisting moment. Ayan, ano, so yung ating force and then yung kanyang perpendicular distance, that is yung ating R. Okay, so ano yung ating formula ngayon dyan? So let's define yung ating formula ngayon dito sa ating maximum shearing stress. Okay? So let's say class, meron tayong ganitong setup. So yan yung derivation natin. Ano po? Ayan, so tau max is equals to T1 plus, so tau 1 plus T2, which is the tau 1 is the direct shearing or direct shear stress, and the tau 2 is the torsional shearing stress. Okay, so ayan yung ating setup. Let's consider this setup. So again class, itong ating yung ating wire na to is, sabi nga dyan siya ay round rod, ano, so kaya yan ay round po yan, round rod. Okay, so we have a diameter here. Ano po? So given na meron tayong force P dito, ano pa ba yung mga, so hindi lang dito yung ito lang yung pinakita na na force. Syempre yan yung nasa baba, pero alam nyo ba na na-experience din yung force ng paghilang na yan dito sa part na to, and dito sa part na to, and sa part na to, sa part na to. Ayan, so kapag hinila mo siya, hindi lang naman to yung nahila, kundi lahat na nakakonect na dyan. Okay, so ayan, finding the direct shear stress. So yung munang tau 1 ang ating hahanapin class. So dito ay, di ba yung sinabi ko sa inyo na pag nag-apply tayo ng force dito, ano po, ayan, so nagkakaroon din, na-experience din ng mga, ito, yung mga force. So may force, actually may force din dito, na-experience din na dyan. Ano po, kasi yung paghila. Ngayon, we have the force P, and finding the direct shear stress. So saan ba nangyayari yung direct shear stress natin class? So ayan, so let's say dito, ito, i-consider lang natin tong part na to, ayan, so pwede naman din yun, so ito lang yung malapit, pwede din doon, so ito, let's say yan, para-pares naman, ano po, so ngayon, let's consider itong area natin, round siya because we have a, di ba meron tayong round rod dito, yung ating wire. So given na meron kang area here, may area yan, and subjected siya sa force, okay, so ano mangyayari dito sa part na to class? So ano kaya mangyayari class? So tama po, magkakaroon siya ng stress. May stress to class kasi because meron kang, di ba, ang stress natin is force over ng ating area. Okay? So mangyayari, may stress to ngayon itong area na to kasi may force na in-apply sa kanya. And that stress class, itong stress na naranasan niya, is what we call direct shear stress. Ano po? So, bakit shear stress? Di ba class, pagka hinila natin ang spring natin, ano bang tendency niya? Ano po? Di ba mayroong siya ay nagkakaroon ng pag-slide sa siya ay parallel, ano po. So therefore, ang nakikreate natin na stress dito sa ating helical spring is yung ating shear stress. Ano po? Dun sa pinakaloob ng ating wire na ito. Nagkakaroon siya ng shear stress dyan. Ano po? That is what we call direct. So, direct siya. Direct shear stress. Ano po? So, yung shear stress dyan, direct shear stress dito. So, yan yung dumadagdag na stress dun sa ating helical spring. And pagka sobrang laki ng naka-apply na load, so ayan, it will result to error or damage. So mapuputol yung ating spring. Okay, so ayan, ano ba yung formula natin? Again, yung ating force over ng area, force dun sa shearing, and then yung area being sheared. Okay, so yan, dahan-dahan siyang napupunit. Ano po, kapag yung ating load is enough, just enough to kasi mapunit, madamage, or magka-error yung ating system. But if not, so makaka-experience pa rin siya ng shear stress. Okay, so force over area, where area is, ayan, so since yan ay round, ano po, round rod, ano po, so we have despite the raised to 2 over ng 4 sa kanyang area. Ano po, para sa kanyang area. Okay, so that is our tau sub 1. Okay, so that is our direct shear stress. So now class, we are going to find the next, ano po, so yung ating tau 2, which is yung ating torsional shear stress. Okay, so ayan, again, meron pa rin tayo ditong force, ayan, and yung ating area. Ngayon, saan ba nagtitake place yung ating torsional shear stress na yan? So let's find out. Ayan. So as you can see class, eto, so yung dalawang points na yan, ano po, yung bumubuo sa helical spring natin, subject siya sa force doon. So, ayan, tingnan natin etong setup na to. Okay? So, ano yung ating madi-discover dito? Ayan, ating dun sa setup na yan. Okay? Ayan. So, kita nyo class, so, nilagay lang natin dito. Okay? Ipalakihin lang natin. Ano po? So, ngayon class, may force P ka dito, may force P ka doon. So, alam naman natin yan. Okay, so di ba para magkaroon ng equilibrium, yung ating spring ngayon, magkakaroon ng resistance force para dun sa mga applied force. Ano po? Ayan. So, at isa pa class na mangyayari dyan, ano ba yung mapapansin nyo class pag kayo ay nagbabatak ng spring. Ano? So, hindi naman yung malalaking spring kasi hindi nyo mababatak yung ano lang, let's say yung spring lang ng notebook. Ayan. Ano po, ano mapapansin nyo? Diba pag binatak nyo, nade-deform siya. At ano pa yung nakikita nyo pa dun sa kanyang mismong mga turns. Okay? So, diba habang binabatak natin siya class, nagkakaroon siya ng twist. Tama po ba? Nagtutwist siya. And kapag sobra yung twisting niya, it will result sa pagkaputol or nagkaka-error siya. So, nagkakaroon siya ngayon ng twisting moment. Okay, class? Diba? Nagkakaroon siya ng twisting moment. Ngayon, yung twisting moment na yan is what we call the tawag na sa twisting moment yan. Yan po yung torque. Okay? Twisting moment. Ano po? Yun yung ating torque. Okay, so, tapos, ano ba yung formula natin for twisting moment? For the torque. So, torque is equals to P times yung kanyang perpendicular distance. Since siya ay twisting moment, di ba, ang moment natin is force times yung kanyang perpendicular distance. Ayan, so, torsion or torque is a twisting moment. Ayan, so ngayon kuhanin natin yung ating tau, torsional shearing stress or torsional shear stress gamit yung ating general formula para sa torsional shear stress. So we have this TR over ng J, and then yung ating tinayan, yung ating torque is, di ba, na-discuss natin kanina, siya equals to PR, and then yung R natin in terms ng diameter, we have D over 2 over ng J natin, which is, so tanda naman natin yan na pi D raised to 4 over ng 32. So ngayong class, yan, simplify lang natin. Dito mag-cancel, mag-cancel yan. So magiging 3 na lang. And then ito class, what if, ayan, pwede ba natin itong iakit dito? Ayan, so pwede naman. Yan, iakit lang natin diyan. So ang mangyayari ngayon, kapag inakit mo yan, 32 divided by 2. So we have the 16. Kaya po may 16 dyan. PR, and yung ating natira na pi D raised to 3. And that is our tau 2 or torsional shearing stress. Yan yung ating torsional shear stress or torsional shearing stress. So, ayan, nakuha natin yung dalawa. So, i-add lang natin. So, finding the maximum shear stress, we have the tau 1 plus tau 2 is equals to P over ng pi D raised to 2 over 4 plus 16 PR over ng pi D raised to 3. And then, simplify lang natin class ito. So, class, ilagay ko lang yung 4 dun sa taas para mas maganda at mas malinis siya tingnan. Okay, so nalagay ko lang dun sa 4P pi D raised to 2 plus 16 PR and over ng pi D raised to 3. Ngayon class, i-factor out natin ngayon ito para mas simplify natin siya. Since meron siyang common. So, ang ginawa ko class, ayan, inilipat ko lang itong 16 din para mas madali siya i-factor since, ayan, ko lang siya dito and then factor ko na. So 16 PR over ng pi D raised to 3 is equals or times 1 because diba times 1 so siya yun plus to be able to get the 4P, so we need to divide 16 by 4 and multiply by R, so makakancel yung R kaya magiging 4P na lang and then dito naman para maging pi D raised to 2. So, ilagay lang natin nandito. So, mag-cancel lang siya. Pag na-cancel yan, so, matitira is pi D raised to 2. So, ayan. So, ito ngayon class, yung tinatawag nating maximum shear stress. Okay, o yung tau max. Okay, yan yung ating working formula. So, I hope na na-appreciate niyo po yung ating derivation and may nakuha kayo doon. Okay, so light spring is equals to tau 1 plus tau 2 equals siya sa P. So, ito yung ating ginawa na P over ng pi D raised to 2 over ng 4 plus 16 PR pi D raised to 3. And then, so, nag-come up nga tayo dito. Okay, so this formula neglects the curvature of the spring. Ayan yung ating mga assumption dito. So, it neglects the curvature of the spring. This is used for light spring where the ratio is D over ng 4R, which is, yan nga, small lang. So, the next one class is heavy spring. For heavy springs, and considering the curvature of the spring, a more precise formula is given by, so itong formula natin is what we call AM Walls formula, where yan, nadagdag is yung ating Walls factor and yung ating M, which is the spring index. Okay, so is yan yung ating tau max is equals to 16 PR over ng pi d raised to 3 times the quantity form m minus 1 for m minus 4 plus 0.615 over ng ating spring index. Okay? So, yan, where m is the code is the spring index, and for m minus 1 over ng 4m minus 4 is the wall factor. Okay, baka kayo ay nagtatanong kung paano, ano sir formula natin, ano pong formula natin para dito sa m, in getting the value of m. So, meron tayong formula dyan, class. In getting the value of m is equals to diameter ng ating helix over ng diameter ng ating wire. Or kapag ang given naman is a radius, so you can use 2r over ng ating r. So that is our value ng spring index or yung kanyang formula. Okay po? So the next one is yung spring deformation naman natin, class. Okay, so ano pa yung spring deformation? So spring deformation, the elongation of a bar is, ayan, so we have the delta is equals to 64 p raised to r 3 n, okay, over ng gd raised to 4. So we have this 64 and then yung ating force, okay, and then yung ating mean radius, and ano pa nandiyan natin? So yung mean radius natin, yung ating force, and is the number of turns, g is the shear modulus, and ayan yung ating smaller d is the diameter ng ating wire. Okay, so ayan yung ating elongation, which is delta. Yan, sign ng delta. Okay? Next one, class, is notice that the deformation delta is directly proportional to the applied load P. The ratio of P to delta is called the spring constant and is equal to, so ito na class yung ating spring constant, which is K is equals to P over ng delta is equals also to G times D raised to 4 over ng 64 R raised to 3 times N, wherein ito ay naka-Newton per mm. So, ayan, yung pang-last natin is spring in series and spring in parallel, class. So, for two or more spring with spring laid in series, the resulting spring constant K is given by, so 1 over K is equals to 1 over K1 plus 1 over ng K2, where K1 and K2 are the spring constants for different spring. Okay? So, ano ba yung ating goal dito? Kung bakit yan? Yun yung ating formula. So, let's derive, class. So, ang pinaka gusto natin sabihin dito, class, ano po, is that yung ating, di ba, kumapas yung we have K1 and K2 here. So, K1 and K2, ayan. Okay? And ang gusto natin, class, is yung makuha natin is value ng K, which is yung value ng K is the total. Yan, yung total natin, ano po, even at kung mapapansin nyo kasi diba magkaiba siya ng kanyang size. Ayan, so magkakaroon tayo ng assumption na isang buo na lang siya and same ng maabot ng kanyang length yung sa original. Okay? So let's derive na po the formula. So dito class, ayan, di ba initially yung kanyang ano ay eto. So kung mapapansin nyo, ayan, initially. So ayan. Ngayon class, subjected siya sa load. So yan, kasi subjected siya sa load. Mangyayari ngayon class is mababatak siya. Okay, pag nabatak siya, okay, magkakaroon ng deformation. At hindi lang, take note, hindi lang dito sa malaki, kundi ganun din sa smaller wire. Yan. So yun yung ating tatalakayan ngayon. So dito from the original up to the yung nadagdag, we have, so ilan yung almost, ayan, 3 na turns yung ating delta 1. How about delta 2? Ayan, so medyo, yan, maliit lang naman. So, okay, yung naging deformation is napakaliit naman. Okay? Okay, so, yan yung ating delta. So, find the total delta or elongation. So, we have delta 1 is total delta is delta 1 plus delta 2. So, yan class, yung ating delta. Ano yung ating delta? Ngayon, let's proceed naman dun sa mga forces acting dun sa ating body. So, forces, ayan. Okay, so let's say class, di ba hinilan ngayon yung ating spring. So, mangyayari class, mababatak talaga siya. Ngayon, to maintain the equilibrium na dito sa body, kasi meron tayong applied force, so yung applied force na yan maging unbalanced or hindi sa equilibrium yung ating body. So in order to be in equilibrium yung ating body, yung ating spring, produce siya ng resistance, which is what we call P1 doon sa paghila natin sa yung paghila ng force P. So ngayon, para mag-determine ang kanyang value, so mag-summation tayo ng forces horizontal. So mangyayari lang ngayong class is yan. So left and right. So mangyayari, P1 is equals to the value of P. Okay? How about dun sa pangalawang spring? So nagkaroon din ng paghila ngayon, magkakaroon ng contra or resistance si bar number 2. That is what we call P2. Okay? So, summation of forces 0 is equals to 0 is equals, ang mangyayari, P2 is equals to P na din. Okay? So, ayan. And then, yung ating value ng K, o yung ating sinasabi kanina na yung ating K is equals to P over ng ating delta. Okay? So, delta again is delta 1 plus delta 2. And we are focused for this time in getting the value ng delta 1 or elongation 1. So, K is equals to P 1 over ng delta 1, which is also equal to in getting the value of delta 1. Ano po? Ayan. Para makuha natin yung value ng delta 1, so we use yung ating P1 over ng K1. So next, so doon naman tayo sa delta 2. Delta 2 naman ang ating hahanapin. Itong delta 2 ngayon. Okay? So for delta 2, so makikita natin dito napakalit ng kanyang deformation. Okay? Delta 2 is equals to ayan. Yung ating K2 is equals to P2 over ng delta 2. That is, delta 2 is equals to P at 2 over ng K2. So, yun yung ating magiging formula for getting the delta 2. Okay, class. So, now, meron na tayong value. So, yung value ng K natin is, yun nga, K is equals to P over ng delta. Okay? Tapos, ngayon, class, in terms ng ito, yung ating maging pattern is this one. Delta is equals to total delta is equal sa delta 1 plus delta 2. Okay? Ngayon, i-substitute na natin yung value ng delta dun sa ginamit natin kaninang relationship ng K, delta at saka P. So, from that, we can simplify the equation that is delta T or total is equals to 1, okay? So, ngayon class, we have the value ng delta 2. Okay, delta 2. Ngayon, kuhanin natin ngayon yung ating gamit itong total delta is equals to delta 1 plus delta 2. So ngayon, kuhanin natin yung equation ng K equivalent. Ano po? Gamit itong ating formula na to dito sa ating elongation. Ayan. So, di ba tandaan natin yung K is equals to P over ng ating delta. Since delta yung ating hinahanap, so we get this delta. Ayan. Delta is equals, so the total delta is equals to P over ng yung ating K equivalent. Ano po? Is equals to P1 over ng K1 plus P2 over ng K2. Okay, ngayon class, may relationship tayo, di ba, na yung ating daw P1 is equals to P and P2 is equals to P. So, mean to say class, pwede natin to tanggalin kasi pare-pares naman sila ng value. So, mangyayari lang class, 1 over ng K equivalence is equals to 1 over ng K sub 1 plus 1 over K sub 2, or kung ilan man ang inyong since dalawa lang yung ating wire dito, so dalawa lang yung ating nakuha. So pagka nadagdagan pa yan, so plus 1 over K3 plus 1 over ng K4. At kaya dun po nagmula ang ating formula class. Kung makapansin nyo, same po. Ayan. Ano po? Okay. So the next one is spring in parallel. So, ang kanya naman formula class, kung mapapansin natin, so K is equals to K1 plus K2 plus K3 plus K4 kung ilan man. Ano po ang inyong spring niya. So, let's proceed. Ayan, for the illustration, derivation din natin, paano natin nakuha yung ating formula na yan. So, we have this initial setup, and then class, di ba, pag binatak natin to, so, alam naman natin, may stress yung ating wire, magkakaroon ng elongation. So, ano yung magiging itsura niya, class? Ayan. So, karoon siya ng elongation, and ito, stress yung ating mga wires na yan. So, ngayon, hanapin muna natin yung mga elongation. So, we have the elongation 1, elongation 2, and elongation 3. And ano ba yung makapansin natin for elongation 1, 2, and 3? Kung makapansin natin class, ano yung relationship niya po sa isa't isa? At paano natin makukuha yung ating delta T or total delta? Tingnan yung mabuti, ano ba yung sinasabi dito? So, tama po. And class, kung mapapansin natin, we have the delta, yung ating total delta is equal to delta 1, delta 2, and delta 3. Kung sakali class, meron tayong spring pa na 4, na 5. So, mangyayari class, equal din ang kanilang deformation. Okay? So, since they are in parallel. So, the next one class, yun naman i-consider natin yung mga forces niya. So, when a force is applied, nagkaroon ng paghila, so yung ating wire 1, again, magre-resist siya, magka-apply ito ng resistance, so magkakaroon ng P1 doon. And also yung second wire, magkakaroon siya ng laban or ng resistance against dun sa P, or in order to maintain the equilibrium. So magkakaroon ng force P, and also yung ating last wire, magkakaroon din siya ng pagkontra doon. So ano nga yung relationship ng ating P dun sa ating P1, P2, and P3? So tama po, ayan. P is equals to P1 plus P2 plus P3. Lahat ng forces, okay, or yung force na in-apply natin dun sa certain body, that kapag siya ay naka-parallel, is equal dun sa individual resistant force na in-apply ng body against dun sa ating applied force. Okay? Ayan, so yun yung value ng P. Okay? And now, to get the K equivalent, ayan. For this time, in parallel, we consider yung ating P naman. Ano po? So, yung P naman ang ating consider dito. So, para makuha natin yung value ng P, we have the K equivalent times the ating delta. Ayan. So, K equivalent is equal, K equivalent times delta is equals to K1 delta 1 plus K2 delta 2 and plus K3 delta 3 and so on kung meron ka sa inyong sinasolve na problem. So ngayon, since tatlo lang yan, at since then na yung ating delta total delta is equals to delta 1 equals to delta 2 is equals din sa ating delta 3. Ano po, katulad ng sinabi kanina. So, mean to say, we can cancel this, or yan, para siya ay kasi pare-paras lang din naman siya para mas madali yung computation natin. So, it will result to K equivalent is equals to K1 plus K2 plus K3, or yung ating K, which is, it looks like this or looks familiar. Ayan. So, dyan po nanggaling class yung kanyang formula. So, I hope that you appreciate the derivation, and ayan, we can use the formula sa pag-solve ng ating problem. Okay, so problem solving na po tayo. For sample problem number 1, okay, pakihandahin yung mga ballpen, calculator, and yan yung ating sulatan. Okay, so isang malinis na papel para sa inyong sulatan. Determine the maximum shear stress and elongation in a helical steel spring composed of 20 turns of 20 mm diameter wire on a mean radius of 90 mm when the spring is supporting a load of 1.5 kN. Use G, or yung ating shear modulus, is equals to 83 GPa. So let's now solve the problem. So let's now proceed to class given. So we have P, or yung ating applied force, that is 1.5 kN. So, gaya na ginagawa natin class sa mga nakaraan, kino-convert na natin siya sa mga unit na makakancel natin agad siya para mabilis na lang tayo sa pag-compute. So, dito, ano ating nilagay? So, P is in Newton na. So, yung radius is naka-mm naman. Yung diameter natin, naka-mm na. Ayan, yung ating turns. And, ayan. So, class, so bakit tayo gumamit ng M ngayon? So, as you can see, class, yung ating problem is, ayan, yung force applied is 1.5 kilonewton, which is 1,500 newton. So, class, kapag ganito na yung ating load, 1,000 more than 1,000 newton na. So, we consider it as a heavy spring na yung gagamitin natin po. But if it is less than 1,000 or mas mababa, paano po? Ayan, so that we use light spring lamang. Okay, since ito ay more than 1,000, no? So yun ay isang clue para sa atin that this is under the heavy spring. So that's why kumuha tayo ng value ng M. That is M, since ang bigay lang sa atin is radius, so magiging 2R over ng diameter ng ating wire. That is 2 times 90 over 20, so we get the value which is 90. So the next one is the required, that is the maximum shear stress and the elongation. Formula to be used, ayan, so we have this formula, yung ating formula kanina. For maximum shear stress and yung ating elongation. So finding the maximum shear stress, so substitute lang yung ating mga value, okay, and ayan, so diba class, 16 times yung force mo, which is 1,500 newton, times yung ating radius, that is 90 mm, so and over ng pi 20 mm raised to 3. So ngayon class, di ba magka-cancel natin to? Yan. So matira ngayon is Newton mm squared. Yan. So dito wala namang magka-cancel. So mangyayari class, ang ating sagot is naka-Newton per mm squared, or what we call, yung familiar sa atin is naka-MPa. Okay? So ano kaya yung ating magiging value of class ngayon? Sige, compute po. So the value is, ayan, we have the value that is 99.8737 MPa. So ayan, naka-round up na po siya, and I hope na nakuha nyo din po yung itong sagot na to, same time po. So the next is the elongation. So yung formula natin, and i-substitute lang natin yung ating mga formula. So dito class, okay, in-express na natin ang ating GPa to MPa in order for us para cancel na natin yung ating mga units. So yan, makakancel si Newton, si mm squared, ayan, makakancel din ito. So matitira dito is, ayan, makakancel dito, ayan, madalawa na lang to. So ito makakancel, so at saka ito, ayan. So meron lang tayong unit na mm. Okay. So ano class ngayon ang ating magiging sagot dyan? So the answer is 105.3976. So I hope na nakuha niyo rin po itong ating sagot na ito. And let's now check if our answer is tama or is right. Okay, so tama naman yung ating sagot class. So that would be all, class, for this tutorial, and thank you. I hope that you get something and you learn something from this tutorial, and don't forget to like, share, and subscribe for more tutorials. So thank you, class, and God be all the glory. So thank you, and keep safe, everyone. God richly bless you.